14 seconds after you leave the airlock without a suit, your body starts to betray you. Not because space is cold, not because it is hot, but because it is nothing. The pressure drops towards zero, and the liquids inside you stop behaving like liquids. Moisture on your tongue begins to bubble. The thin film in your eyes tries to evaporate. Gas expands in places it was never meant to exist. If you panic and hold your breath, your lungs can tear from the inside because air expands faster than you can fight it. And the worst part is the silence. There is no air to carry sound. You could scream until your throat ruptures and the universe would not hear a thing. That isn't science fiction. That's physics, indifferent, clean, and absolute. We love the story we tell ourselves instead. We imagine rockets as ladders to the stars. We watch astronauts float calmly outside a station, waving at cameras like space is just another job site. Dangerous, sure, but manageable. We talk about Mars like it's the next continent. We talk about interstellar travel like it's a matter of better engines and more funding. But there's a question we avoid because it ruins the dream. How far could you really go, right now, with real technology and a real human body before you die? Not in a movie, not in a future where everything works. In a universe we actually live in, with the biology you actually have, under laws you cannot negotiate. Tonight we're going to travel outward, not to the stars, but to the edge of what a human can endure. Kilometer by kilometer, orbit by orbit, past the zones where we can limp along, into the regions where survival becomes a countdown. And by the end, 3 uncomfortable truths will be impossible to unsee. 1. There's a barrier in space that kills humans even inside the most advanced spacecraft we can imagine building, and it's closer than you think. 2. We've already pushed people toward that barrier, and some came back changed in ways we still struggle to fully explain. 3. Physics itself places an ultimate limit on how far any civilization can travel, one that technology can't simply upgrade away. So let's start with the comforting version you learned in school. Space begins at 100 kilometers. That line has a name, the Kármán line. Above it, the atmosphere becomes so thin that normal aerodynamics stops making sense. Wings stop working the way they do for airplanes. To stay up there, you must move so fast that you are essentially falling around Earth, missing the ground by outrunning the curve of the planet. That's the official boundary. It sounds neat. It sounds clean. Your body doesn't care, because the first real boundary is much lower and much nastier. At around 19 kilometers above sea level is what flight medicine calls the Armstrong limit. Here the air pressure becomes so low that water can boil at roughly body temperature. You read that right. At a certain altitude, boiling no longer requires heat. It requires only a lack of pressure. This is where the nightmare begins if your protection fails. You won't explode like a Hollywood balloon. Your skin is tougher than that, but you will swell. Gases will expand inside tissues. Bubbles can form where blood and fluids were meant to stay smooth and stable. Your saliva can fizz. The moisture in your eyes can start to vanish. Inside your lungs, the environment becomes hostile to the delicate exchange that keeps you alive. And that's at 19 kilometers, a height weather balloons reach, a distance you could drive in minutes on highway. Now imagine you're inside a sealed capsule or a high-quality suit. Pressure is held at a safe level. Oxygen is regulated. Heat is managed. You feel almost normal. Good, because the next lesson in space is a lesson about temperature that most people get wrong. Up around 80 kilometers, you enter the thermosphere. Here, if you measure temperature by how fast molecules are moving, the numbers can climb to 1,000 degrees Celsius or more. That sounds like an oven, but the air is so thin that those molecules cannot deliver that heat to you. You don't get roasted by a blazing sky. You lose heat by radiating it away into emptiness. Space teaches a brutal rule. Temperature is not what you feel. Temperature is an accounting problem. Energy in versus energy out. In sunlight, surfaces can cook. In shade, surfaces can freeze. And the transition can happen fast. The International Space Station circles Earth roughly every 90 minutes. That means its outer skin experiences multiple day-night cycles per day. Metal expands, contracts, and groans under stress. Astronauts hear pops and creaks, mechanical whispers that say, "I'm still holding." Even here, close enough to see Earth fill half your window, the environment is already trying to break the machine that keeps you alive. But we are still, in a cosmic sense, sheltered. Earth's magnetic field wraps around us like an invisible fist, deflecting a huge fraction of charged particles that would otherwise slice through living tissue. Which brings us to the first invisible wall that isn't made of vacuum or cold. It's made of radiation, and it starts sooner than most people realize. Beyond roughly 1,000 kilometers, the magnetic field weakens fast. Radiation that once curved away now starts cutting straight through. This is where space stops being hostile and starts being active. Here, damage isn't hypothetical. It's cumulative. Charged particles slam into your body at near light speed. They don't burn you. They don't tear you apart. They pass through you, through skin, through organs, through neurons, through DNA. Each hit is small, almost nothing, but you don't get just one. You get thousands. Medium, relentlessly. Your cells repair what they can. They fail where they can't. Mistakes accumulate, and mistakes are never evenly distributed. One particle might pass harmlessly. Another might strike the stem cell that makes your blood. Another might nick the neuron that holds a memory. Another might damage a cell that will divide incorrectly years later. This is why radiation is terrifying. It doesn't need to kill you today. It only needs to change you. The first major warning sign of this region is something astronauts noticed long before we had good instruments for it. They call them light flashes, even with eyes closed, even in total darkness, even while trying to sleep. Sudden streaks, bursts, pinpoints of light behind the eyelids. Not dreams, not hallucinations. Cosmic rays passing directly through the eye and the visual cortex. The universe announcing itself inside your brain. This isn't damage you feel like pain. It's damage you feel like uncertainty. Now imagine staying here, not passing through, not racing across, but living. If a space station were placed inside the Van Allen belts instead of below them, the crew wouldn't last months. They wouldn't last weeks. Even with shielding, the dose would accumulate faster than the body can compensate. Cancer risk would spike. Neurological damage would begin. Immune suppression would follow. This is why the ISS is low. Not convenient, not arbitrary. Low because above it is slow poison. And here's the uncomfortable truth. Distance in space is not measured in kilometers. It's measured in dose. How much radiation you absorb. How long your biology can tolerate being altered. How much air your cells can survive before the system fails. Which brings us to the moon. 3 days away. That's all. Roughly 384,000 kilometers. In human terms, it feels manageable. Short, close. But the moon lives outside Earth's protective cocoon. Every mission to the moon crossed the radiation belts. Every crew left the magnetic field behind. Every astronaut entered open exposure. Apollo missions survived because of speed. They couldn't linger. They didn't orbit in danger. They passed through narrow corridors calculated to minimize dose. And even then, they saw the flashes. They absorbed radiation. They took risks we rarely talk about now. In August 1972, between Apollo 16 and Apollo 17, the sun released one of the most powerful solar particle events ever recorded. If astronauts had been en route to the moon at that moment, they wouldn't have died instantly. That's worse. Over days, their bone marrow would fail. Their intestines would break down. Their immune systems would collapse. Their brains would swell. They would die slowly. And there would be nothing anyone on Earth could do. They weren't saved by technology. They were saved by timing, by luck. That should make you uneasy, because luck does not scale. The moon is close enough that risk can be rolled like dice. Mars is not. Mars is not 3 days away. Mars is 6 to 9 months of continuous exposure. No magnetic shield, no quick return, no sprint through danger, just endurance. And endurance is exactly what radiation does not allow. In part 3, we'll stand on that thin line between survivable and irreversible. We'll look at what happens when exposure isn't a crossing, but a lifestyle. 3 days. That is all it takes to reach the moon. 3 days away from Earth. 3 days beyond the magnetic shield that has protected every human life that has ever existed. 3 days does not sound like exile. It does not feel like danger. It feels temporary. That feeling is a lie. Because the moon is not dangerous in the way we expect danger to look. It does not threaten you with violence. It does not announce itself with explosions. It simply removes protection and waits. The moment a spacecraft leaves Earth's magnetosphere, the rules change. Nothing alarms. Nothing breaks. No system fails. Life support continues to function. Air remains breathable. Temperature stays stable. Everything feels normal. And that is exactly why the moon is lethal. Radiation does not behave like fire or impact. It does not burn. It does not strike once and stop. It passes through metal, through flesh, through cells, through DNA. The spacecraft walls slow some of it. They cannot stop all of it. Cosmic rays are not particles you can fence out. They are energy, and energy does not ask permission. Apollo astronauts were the first humans to ever live fully exposed to this environment. They were not reckless. They were precise. Trajectories were calculated to reduce exposure. Transit times were minimized. Every kilogram of shielding was carefully weighed against fuel and speed. Even with all that effort, radiation still got through. Astronauts described seeing sudden flashes of light. Not outside the window, inside their vision. Eyes closed, dark cabin, still light. At first, they thought it was fatigue, stress, imagination. Later, physics provided the explanation. High-energy cosmic particles were passing directly through the retina and the visual cortex. Each flash was a particle moving faster than evolution ever prepared the human brain to understand. No pain, no warning, just information being written where it does not belong. This is not science fiction. It is documented, and the effects do not stop at perception. Radiation damages cells silently. DNA strands break. Repair mechanisms fail. Errors propagate. Most of the time, the body copes. Sometimes it does not. Cancer risk increases. Cognitive function can subtly change. Immune response weakens. Not immediately, not dramatically, but permanently. Apollo astronauts were exposed for days. That exposure was survival. Barely. Now consider what almost happened. In August 1972, between Apollo 16 and Apollo 17, the sun released a massive solar particle event. One of the strongest ever recorded. The timing was almost perfect, almost lethal. Had astronauts been traveling to the moon during that storm, there would have been no shelter, no magnetic field, no planetary mass to hide behind, no atmosphere to absorb the blow. The spacecraft would have become a funnel for radiation. The astronauts would not have died instantly. That would have been mercy. Instead, radiation sickness would unfold over days. Bone marrow would stop producing blood cells. The intestinal lining would fail. The immune system would collapse. Infections would become unstoppable. Internal bleeding would follow. Death would arrive slowly, and Earth would only be able to watch. Apollo did not succeed because space was safe. Apollo succeeded because nothing went catastrophically wrong at the wrong moment. That distinction matters, because it means safety was never guaranteed. It was borrowed, on time, on probability, on silence from the sun. The moon teaches a lesson that no engineering diagram likes to admit. At this distance, survival depends on luck. Luck with solar activity, luck with exposure duration, luck with individual biology. Some bodies repair damage better than others. Some brains are more resilient. Some immune systems recover. Some do not. The moon does not care which one you are. Now imagine extending this environment. Not for 3 days, not for a week, for months. Mars is not a harder version of the moon. It is a fundamentally different problem. The moon allows for retreat. Mars does not. On a lunar mission, danger has an exit. Turn around. Burn engines. Go home. Mars removes that option entirely. 6 to 9 months outbound. Months on the surface. 6 to 9 months back. Radiation does not pause during transit. It does not slow down while you sleep. It does not negotiate with mission planners. Every hour adds dose. Every day increases risk. Every month compounds uncertainty. And unlike hardware, the human body cannot be rebooted. Cells remember damage. DNA remembers errors. Brains remember disruption. By the time you reach Mars, the question is no longer, can you survive? The question becomes, what version of you arrives? In Part 4, we will follow that question into uncomfortable territory. We will examine what prolonged exposure does not just to muscles and bones, but to cognition, to immunity, to decision-making, and to the fragile system that has to remain functional long enough for the mission to mean anything at all. Mars is not far in space. It is far in time, 6 to 9 months. That is how long the journey takes with real engines, real fuel, and real physics. 6 to 9 months where turning around does not save you. 6 to 9 months where every mistake continues moving forward with you. There is a moment on a Mars mission when Earth becomes useless. Not emotionally, physically. At first, Earth is still close enough to imagine rescue. You look back, you know where home is. You know that people are watching. Then one day, the math quietly changes. The fuel required to turn around and return exceeds what you have. The trajectory no longer allows a safe abort. The window closes. From that moment on, Mars is not the destination. Mars is the only option. And this is where radiation stops being a background risk and becomes the dominant force shaping the mission. Outside Earth's magnetosphere, there is no global shield, no invisible wall bending danger away. Only thin layers of metal and plastic standing between human tissue and high-energy particles that have crossed the galaxy. Every second, radiation passes through the spacecraft. Not evenly, not gently, randomly. Some particles strike harmlessly. Some miss vital systems. Some do nothing at all. Others hit exactly where they should not. The problem with long exposure is not intensity. It is accumulation. A single cosmic ray can damage a cell. 1,000 can overwhelm repair mechanisms. 1,000,000 guarantee errors. And on a Mars transit, you do not get a break. Day after day, week after week, month after month, your body works continuously to repair itself. And slowly, inevitably, it falls behind. One of the first systems to suffer is the immune system. White blood cell production becomes less reliable. Response is slow. The ability to fight infection weakens. On Earth, this would be manageable. In space, it becomes existential. A minor infection is no longer minor. A small wound is no longer routine. A latent virus, something your body has carried silently for years, can reactivate. Astronauts have already seen this in low Earth orbit. Herpes viruses reappearing, immune markers shifting, defenses dropping. Mars multiplies that risk. Then there's the brain. Radiation does not respect cognition. High-energy particles can pass directly through neural tissue, altering connections at random. Animal studies show changes in memory, learning, and decision-making after prolonged exposure. Not total loss, not madness, subtle degradation. And subtle degradation is the most dangerous kind in space. Because you do not notice it happening. You only notice the consequences. A delayed reaction, a poor judgment call, a misread display. A decision that seems reasonable at the time and catastrophic later. Now, at isolation, Mars crews are not just exposed. They are alone. Communication delays stretch from minutes to nearly half an hour. You cannot ask Earth for advice in real time. You cannot wait for approval. You cannot be corrected quickly. Every decision is final by the time feedback arrives. And decisions are being made by minds under radiation stress, immune suppression, altered sleep cycles, and microgravity-induced fluid shifts in the brain. This is not a test environment. There is no reset button. Microgravity adds another layer of damage. Muscles weaken, bones lose density, blood redistributes upward, increasing pressure inside the skull. Vision problems appear. Some astronauts experience permanent changes in eyesight after long missions. Mars transit is long enough to make these effects significant. Now consider arrival. You do not arrive healthy and then explore Mars. You arrive already compromised, weakened, irradiated, physiologically altered. Mars does not offer relief. Its atmosphere is too thin to provide meaningful radiation protection. Its magnetic field is weak and fragmented. Its surface receives more radiation than deep space at times, especially during solar events. Shelter helps, shielding helps, but mass is expensive. Every extra centimeter of protection costs fuel. Every kilogram of shielding trades against supplies. There is no perfect solution, only compromises. And the longest compromise is the return trip, because everything you endure on the way to Mars, you endure again on the way back. By then, damage is not hypothetical. It is cumulative. It is written into your cells. Cancer risk rises sharply. Neurological effects may linger for life. Immune dysfunction may never fully recover. Mars missions are not about bravery. They're about acceptance. Acceptance that some risks cannot be engineered away. Acceptance that biology has limits. Acceptance that survival may not mean returning the same person who left. In Part 5, we go beyond Mars, past the point where rescue, return, and even mission success stop being meaningful concepts, where distance turns from a number into a sentence. Beyond Mars, space stops pretending to be survivable. Inside Earth's neighborhood, danger is managed through proximity. Supplies can be sent. Rescue can be imagined. Communication still resembles conversation. Past Mars, all of that collapses. Distance turns every problem permanent. Time turns every mistake final. The asteroid belt is often imagined as a chaotic minefield, but in reality, it is mostly empty. Spacecraft pass through it routinely without incident. The danger here is not collision. It is duration. Every kilometer traveled outward adds days of exposure. Every day adds radiation. Every week compounds biological damage that no system can fully repair. There is no new threat here, only the slow accumulation of everything that has already begun to go wrong. Past the asteroid belt, sunlight weakens. Solar power becomes unreliable. Heat becomes something you must actively generate rather than shed. Systems designed to cool spacecraft near Earth must now prevent freezing instead. Metal contracts. Lubricants thicken. Electronics become brittle. Nothing fails dramatically at first. Things simply stop working the way they used to. Then comes Jupiter. Jupiter is not a destination. It is a warning. The planet's immense gravity creates the most powerful radiation environment in the solar system. Its magnetic field traps charged particles and accelerates them to lethal energies. These radiation belts are not slightly worse than Earth's. They are orders of magnitude worse. Spacecraft passing near Jupiter experience damage within hours. Electronics degrade. Sensors fail. Memory corrupts. Even heavily shielded probes suffer. A human being in Jupiter's radiation environment would not survive long enough for heroism to matter. Minutes, not days. This is not speculation. This is measured physics. Jupiter is surrounded by a region of space that is simply incompatible with complex biology. Its moons do not escape this fate. Europa, often imagined as a promising ocean world, exists inside this radiation hell. Its surface is continuously sterilized. Any life there, if it exists, must hide beneath kilometers of ice. A human standing on Europa's surface without extraordinary shielding would receive a fatal dose in a very short time. Even inside a protected habitat, time would be limited. Exploration would be a countdown. Saturn appears gentler, but the distance alone reshapes the mission. 4 years of travel with current propulsion. 4 years of radiation. 4 years of isolation. 4 years without the possibility of timely help. Communication delays stretch beyond an hour. Emergencies are handled alone. Decisions are made without feedback. By the time Earth responds, the outcome is already history. At this distance, psychology becomes as dangerous as physics. Humans are not built for years of confinement without novelty, without natural light cycles, without new environments. Isolation reshapes perception. Time blurs. Motivation erodes. Small disagreements magnify. Cognitive drift becomes normal. And this happens even before radiation's effects on the brain are fully understood. Past Saturn, the solar system thins into emptiness. Uranus and Neptune are not places humans visit. They're markers of how far we can send machines, not bodies. Travel times stretch into decades. Life support systems designed for months must now function flawlessly for years without resupply, repair, or replacement. Every component must survive vibration, radiation, thermal cycling, and entropy longer than most human institutions last. Then comes the edge of the sun's influence. The heliopause marks where the solar wind gives way to interstellar space. Beyond it, cosmic radiation increases again. There is no shielding from the galaxy, only what you brought with you. And what you brought with you is limited by launch mass and fuel equations written long before you were born. Voyager 1 crossed this boundary after decades of flight. It is still sending data, but it is not alive. It does not repair itself. It does not fear death. A human crew would reach this region already altered beyond recognition by time, radiation, and isolation. Interstellar space is not just far. It is actively hostile to persistence. At even modest fractions of light speed, microscopic particles become weapons. A single atom of hydrogen at near light speed carries the energy of a bullet. Dust grains become explosions. Shields erode, hulls thin. Over long enough time, nothing survives intact, and time is unavoidable. The nearest star is more than 4 light years away. With current propulsion, reaching it would take tens of thousands of years. Even with radical theoretical advances, the journey would span generations. A ship would become a closed ecosystem, subject to genetic drift, cultural collapse, and mechanical decay. It would not be a mission. It would be a fragile civilization drifting between stars, hoping nothing important breaks. But even that fantasy ignores the final barrier. The universe itself is expanding. Distant galaxies are not waiting to be reached. They are receding faster than any ship can chase them. Space is growing faster than travel. There are places that are already unreachable, no matter what technology is invented. Not because we lack power, but because physics forbids pursuit. This is the truth hidden beneath the romance of exploration. The universe does not open, it is actively erasing access to itself. This means it's something deeply unsettling. The observable universe is shrinking, not in size, but in content. As time passes, more galaxies cross the horizon and vanish from causal contact. They do not explode. They do not fade slowly. They simply stop being part of our universe in any practical sense. Now consider what this means for travel. No engine, no matter how advanced, can reach beyond this horizon. No shortcut, no warp, no exotic matter fixes it without violating the fundamental structure of space-time itself. This is not a technological ceiling. It is a cosmological prison. But it gets worse. Because the horizon does not wait for you. It moves inward relative to what you can reach. Every second you delay, fewer destinations remain accessible. Every million years, entire regions of the universe become unreachable forever. Exploration has an expiration date. Eventually, only local structures remain connected. Our local group of galaxies will stay bound together by gravity. The Milky Way and Andromeda will merge. A single massive galaxy will form. Beyond it, nothing. No distant spiders. No clusters. No cosmic web. Just darkness. A civilization born trillions of years from now will look at the sky and see a single galaxy surrounded by empty blackness. They will conclude, logically and incorrectly, that the universe is small and static. They will find no evidence of the Big Bang. No cosmic microwave background. No distant galaxies racing away. The universe will have erased its own origin story. At that point, travel becomes trivial because there is nowhere left to go. But long before that future arrives, another limit asserts itself. Life is not a natural outcome of the universe. It is an exception. The laws of physics if the universe guarantees our erasure, then meaning cannot come from permanence. Nothing we build will last. No civilization will endure forever. No signal will propagate infinitely. Every structure, every memory, every achievement is temporary. On cosmic timescales, even galaxies are brief phenomena. This forces a brutal conclusion. If meaning exists, it cannot be stored in outcomes. It must exist in process. Humans instinctively resist this idea. We want legacy. We want continuity. We want proof that what we did mattered beyond our own brief moment. But the universe offers no such guarantees. Time dismantles everything without malice and without exception. Meaning, therefore, cannot be something the universe grants. It must be something consciousness generates internally, moment by moment, in defiance of inevitability. This reframes survival itself. Survival is not about winning against the universe. That contest is already lost. Survival is about delaying erasure long enough to experience, to understand, and to choose. The value of intelligence is not that it conquers nature, but that it interprets it. A star does not know it shines. A galaxy does not know it rotates. A human knows both, and that knowledge exists nowhere else. From this perspective, exploration is not expansion, but comprehension. We do not explore space to claim it. We explore to reduce ignorance before ignorance becomes absolute again. Every measurement, every equation, every image of a distant galaxy is a temporary victory against cosmic amnesia. Not a permanent one, but a real one. This also changes how we view failure. If everything ends, then failure is not falling short of infinity. Failure is refusing to look, refusing to ask, refusing to think because the answers are uncomfortable. Meaning arises not from success, but from engagement. A question asked in a dying universe still matters because the act of asking is rare. Even suffering gains a different shape. Pain does not become good, but becomes contextual. Struggle is not evidence of cosmic injustice. It is evidence of existence under constraints. Life is difficult because it is improbable. Consciousness is fragile because it exists against the natural gradient of entropy. Difficulty is not punishment. It is the price of being an exception. This also dismantles the fantasy of destiny. There is no promised expansion to the stars, no guaranteed interstellar future, no cosmic role waiting to be fulfilled. Humanity has no assigned mission from the universe. And paradoxically, that absence creates freedom. If there is no script, then meaning is authored, not discovered. What we choose to value becomes more important than what we achieve. Knowledge over domination, understanding over scale, depth over reach. A single insight can matter more than 1,000 conquered worlds, because insight exists only while minds exist to hold it. In this light, even extinction does not fully negate meaning. A thought does not become worthless because it is forgotten. A moment does not lose value because it ends. The universe forgets everything. That does not retroactively erase experience. It only prevents accumulation. Meaning then is local, temporary, personal, and real. We are not important to the universe, but the universe is important to us. And that asymmetry is enough. Consciousness is the universe briefly caring about itself, even if that care leaves no permanent mark. In Part 9, we examine the final paradox. If everything is temporary, why does the instinct to continue persist so strongly? And what does that say about us? If everything is temporary, if extinction is guaranteed, if even the universe itself is on a countdown, then the most puzzling thing is not despair. The most puzzling thing is persistence. Despite everything we know, life insists on continuing. Not abstract life, but specific organisms. Humans plan for futures they will never see. Parents care about children who will outlive them. Civilizations invest in knowledge that may never be used. This instinct survives even when logic offers no reward for it. From a purely rational perspective, this makes little sense. If nothing lasts, why try? If every structure collapses, why build? If every species vanishes, why reproduce? And yet, this instinct is nearly universal. It is older than philosophy, older than language, older than self-awareness. The reason is simple and unsettling. The instinct to continue is not based on meaning. Meaning is layered on top later. The instinct comes from physics and biology. Life exists because matter found a way to copy itself imperfectly. That process, once started, has momentum. Survival does not require justification. It only requires continuation. Natural selection does not select for truth. It selects for persistence. Organisms that hesitate in the face of futility do not leave descendants. Organisms that act as if tomorrow matters, even when it does not in the long run, dominate the future. Optimism, hope, denial, attachment. These are not philosophical errors. They're survival tools. Consciousness inherited this bias. We are not neutral observers of reality. We are shaped by millions of years of selection that punished resignation and rewarded effort, regardless of outcome. The urge to continue is not evidence that continuation has cosmic meaning. It is evidence that systems without this urge did not survive long enough to ask questions. This creates a deep internal conflict. Intellect understands finitude. Biology resists it. One part of us sees the heat death of the universe. Another part insists on making plans for next year. Both are correct in their own domains. The tension between them is what produces anxiety, ambition, art, religion, and science. This also explains why extinction is so difficult to accept emotionally. even when accepted intellectually. On paper, extinction is inevitable. In the body, it feels wrong, not because it is unjust, but because it contradicts the mechanisms that built us. We are designed to experience loss as unacceptable, even when it is unavoidable. The instinct to continue does not point to destiny. It points to origin. We are continuation machines that accidentally became aware of the limits of continuation. And awareness does something strange. It does not erase the instinct. It complicates it. We know the universe ends, yet we still care. We know civilizations fall, yet we still build. We know memories fade, yet we still record. Awareness does not cancel the drive. It redirects it. This is why humans do not simply survive. They create. They tell stories. They leave marks. They try to compress meaning into fragile forms. Words, images, structures, knowing they will eventually decay. Not because decay can be stopped, but because expression exists now. The instinct to continue, once paired with awareness, transforms into responsibility. If nothing is guaranteed, then what exists right now becomes more valuable, not less. A conscious moment is rare. A thinking species is rare. A universe capable of being understood is rare. Rarity creates urgency. We continue not because we will win, but because stopping early guarantees nothing happens at all. In Part 10, the final section, we bring everything together and confront the last question left standing. Given all of this, how should a conscious species live? If everything we have discussed is true, then the final question is no longer scientific. It is ethical, not ethics imposed by the universe, because the universe imposes nothing. Ethics chosen by consciousness in full awareness of its own fragility. A conscious species should live honestly, not optimistically in a naive sense, and not cynically in a paralyzing one. Honestly means seeing the limits clearly and acting anyway. It means abandoning the fantasy of infinite expansion while refusing the temptation of nihilism. The universe does not promise survival, but it allows choice. That is enough. A conscious species should value understanding over domination. Conquest is shallow. Control is temporary. Knowledge is the only thing that grows without immediately accelerating collapse. Understanding does not stop entropy, but it allows coherence within it. A species that prioritizes comprehension can remain meaningful even as its power remains limited. A conscious species should protect continuity where it exists. Not because continuity is eternal, but because it is rare. Life, memory, culture, ecosystems, and minds are not replaceable in practice, even if the universe does not care when they vanish. Preservation is not denial of entropy. It is respect for improbability. A conscious species should design for humility. Expansion without restraint amplifies risk. Complexity without wisdom accelerates failure. Intelligence that outruns responsibility destroys its own foundation. Survival does not require maximum growth. It requires balance between ambition and restraint, curiosity and caution. A conscious species should accept finitude without surrender, knowing that everything ends does not make action meaningless. It makes it precise. Time becomes valuable because it is limited. Attention becomes sacred because it cannot be stored. Care becomes urgent because delay erases opportunity. A conscious species should treat awareness as an achievement, not an entitlement. Consciousness is not guaranteed by the universe. It is not protected. It is not common. It is a fragile arrangement of matter that can easily be undone. To waste it through indifference, cruelty, or ignorance is not tragic in a cosmic sense, but it is tragic in the only sense that matters to those who are aware. A conscious species should remember that meaning does not scale with size. Bigger is not better. Older is not wiser. Louder is not truer. A single mind understanding one true thing about the universe is already an extraordinary event. A civilization that enables many such minds is already remarkable, regardless of how far it spreads. Finally, a conscious species should live as if observation itself matters. Because it does. The universe contains no memory except the ones we create. No reflection except the ones we perform. No questions except the ones we ask. When consciousness disappears, the universe does not mourn. It simply becomes silent again. We are not the point of the universe, but we are the universe, briefly knowing that it exists. That is not a destiny. It is a responsibility, and it is enough.